Hi guys, welcome back to my YouTube channel and we are here now to answer all the activity in chapter 7. Okay, let's start. Chapter 7, IP addressing in 7.1.1.5. Activity binary to decimal conversion. Instruction. This activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommended that you work with these tools until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. Okay, let's start. So, this is the base and the exponent and the position and the bits. So, let's try this one. The available is 16, 4, and 2. So 16 plus 4 plus 2 is equal to 22. So let's check. Okay, correct. Let's try another one. The available is 32, 8, 4, 2, and 1. So 32 plus 8, 40 plus 4, 44 plus 2, 46 plus 1, 47. Okay, another one. Let's try another one. The available number is 32, 8, 4, 2, 1. Again, 32 plus 8 is 40. 40 plus 4, 44 plus 2, 46 plus 1 is 47. So, done to this activity. So, let's proceed to the another activity. Okay, another activity is decimal to binary conversion utility or decimal to binary conversion activity. The instruction. This activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversion without error. Convert the decimal number shown in the decimal value row to its binary bits. So, total of 95. Decimal value is 95. So, 128 is close. So, 64 is open. 64, 32, 96, close. Open. 80. So, open. Then open. I think open. So, let's check. Okay, correct. So let's try another one. 14. Number is 14. So 128 is close. 64 close. So 8 open. 4 is open. 2 is open. Then 1 is close. So correct. Then another example. 60. Given is 60, then 128 is close, 64 is close, 32 is open, then 64, 16 is open, then 8 is open, then 4 is open, then close. So correct. The another last one, the 16. Close, open, close. So okay, it's correct. Then let's proceed to the next activity for chapter 7. Next activity for chapter 7 is logical and operation. So is 1 and 1 is equal to 1. Then 0 and 1 is equal to 0. And 0 and 0 is equal to 0. And 1 and 0 is equal to 0. So the next activity is adding to determine the network address. Instructions: use the adding process to determine the network address in binary and decimal formats. So host address, subnet mask here, then host address in binary and subnet mask in binary. So network address in binary is 101.0.1.1.0.0, then 0.0.0.1.1.0.0.0, then 1.0.0.1.0.1, then 1.0.0.0.0. So network address in decimal, then this is 172, then 124.8.12, 124.8.12 is 20, 16 pala. So sorry, 624, then 128 plus 16 is 149, then this is 128. So let's check. So correct. And so let's try another one. Another one is 1.0.1.0.1.1.0.0, 0.0.0.1.0.0.1.0, 0.1.1.0.1.1.0.0, then 0.0.0.0.0. So 128, then 32, then 8, and 4 is 172, then 1, 2, 4, 8, 16, 16 and 2, 18, then 64, 32, 96 plus 100, 96, ito 108, then 0. Let's check. Okay, it's correct. Okay, last example is 1, then 1, 2, 3, 4, 1, 0, 1, 0, then 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, then 0, 0, 0. Then network address in decimal is 4, 8, 10, then 4, then 32, then 0. Okay, it's correct. Yeah, this activity is done. So next, let's proceed to the next activity in chapter 7. The next activity in chapter 7 is unicast, broadcast, or multicast. So the instruction is click start to view the destination IP address. Next, click the host which will receive a packet based on the address type, unicast, broadcast, or multicast. This is a time activity. So let's try this. Okay, start. 12. So it 12.168.100.2. So this one. Okay, you have successfully identified the transmission type. So another one. 5.5. So 6.5. Then successfully identified the transmission type. The last one, 192.16. Okay, this is the 0.5. Okay, last try for this activity. 192.168.100.2. So I think this is 0.2. This 100.2. Okay, you have successfully identified the transmission type. So let's proceed to the next activity for chapter 7. Okay, let's try pass or block IPv4 address. This instruction decide to pass or block each IP address depending on whether it is public, the internet, or private small local network. Click start to begin. Okay, let's start. Pass. 146 is pass. Oh man. 142 is pass. 132 also pass. Then 172 pass. Okay, we earn 10 points. So you have successfully identified public and private address. So let's try another one. Another one. Let's try 192 block. 1 pass. 127. 192 is block. So 143 is pass. Then 192 is block. So it's done. So let's proceed to the next activity. Next activity, chapter 7 is public or private IPv4 address. The instruction is drag each IP address to the correct category, public or private. So let's first public. The public is 64.104.2.22. Then another public IP address is 209.165.201.30, and another public IP address is 192.3.0.3.15, and the rest IP address is private. So let's check. Okay, you have correctly identified all the IP address. So let's proceed to the next activity in chapter 7, where is IPv4 issues and solutions. For 5 term and description here. So instruction, drag the IPv4 or IPv6 term to the field next to the appropriate description. So the first is 128-bit address or 340 undersilion addresses is IPv6. Then 32-bit address or 4.3 billion addresses is IPv4. IPv4 is bigger than IPv6, always bigger than IPv6 is always bigger than IPv4. So the next is transport an IPv6 packet over IPv4 network. So tunneling. Now, to transport an IPv6 packet over IPv4 network, tunneling. Then uses NAT64 to convert between IPv6 and IPv4. So convert between means translation, and the last is allows IPv4 and IPv6 to exist on the same network segment dual stop. So let's check. Okay, all correct, and IPv4 issues and solution are done. Then let's proceed to the next activity. So the next activity is practicing IPv6 addressing representation. So the instruction is convert the IPv6 addresses into short, omit the leading zeros, and compress form. Use the numbers at the bottom of the page to continue the activity. This activity. So prepared format, omit leading zeros, and compressed format. So let's try. 0 to 2001, then have 40, you write only 10, then begins in 0, do not type the 0, so db8, then 1111, then 0 0 0, and then 200. So compress the form. 211 0, then db8, then 1111, then 30. So do not write it to 200. So let's check. Okay, correct. So let's try another one. So 0 0 0 0 0 0 0, then 1. So compress format is, so all the 0 is right like this, then write 1. So correct. Then let's try another one. 111 0 0 0 0 0, then 101 111. So it's the answer. 111, then do not write this all 0. So let's check. Correct. Okay, practicing IPv6 address representation is done. So let's proceed to the next activity in chapter 7, which is identify types of IPv6 addresses. So the instruction is drag the IPv6 address type to the most appropriate description. So 3 terms and description here. So let's start. Unique internet routable IPv6 addresses or dynamic or statistic. So this one is think global unicast. So FE801 is link local, then 2001 db8 ACAD, then 1 or over 64 is global unicast. And then typical IPv6 prefix used to indicate the network portion of the addresses is /64, and the last is used to communicate with other devices on the same IPv6 subnet is link. So I think it's done. So you have successfully matched the IPv6 address types to their descriptions. So this activity is done. So let's proceed to the next activity, where is so it's the next activity. So verifying IPv6 address configuration. So enter the show command that will display a brief summary of IPv6 status. So input the show IPv6 interface brief, then they have gigabyte ethernet 00, gigabyte ethernet 01, and serial 000 and serial 001. So unassigned, then enter the show command that will display the IPv6 routing table. So input show IPv6 route. So routing table default 7 entries. So 7 entries, 1 2 3 4 5 6 7. So directly connect. See direct via gigabyte 00 directly connected. Then verify connectivity to PC2 at 2001 db8 ACAD 110. Then ping. Then type escape sequence to abort. Sending 100 bytes ICMP chose to 2001 db8 ACAD 110. Timeout is 2 seconds. Success rate is 100%. So you successfully verified the IPv6 address configuration. So I think this is the last activity for chapter 7. Let's see. So that's all for chapter 7, and thank you for watching.